What's going on, everybody? This is Mr. Diamond, and we're going to be working out the example problems for R and S configuration. So if you don't already have things ready for this, what you are going to want, most likely the way I do this and the way I'm going to kind of explain this, you don't need it, but it's a lot easier if you have some sort of coloring. I've got colored pens, and it's even better if you can get these pens to match up with the colors that you're actually going to be using on your molecule kit, or at least close enough. So I'm going to be using red, green, blue, and purple. You should have all of these in your kit. And even though some of these structures are bigger, we're only going to really use these four, and then we're going to use, I've got my one carbon that has all of my bonds attached to it. So let's go ahead and let's start with this. So what I'm going to do is I'm going to, let me rearrange this slightly. Every single one of these structures that I do, we're going to try to get them in priority, just like we did for our double bonds. My lowest priority is always going to be this green, then this red, then this blue, then this purple. This is not how I used to do it. So if I mess this up at some point and don't do it that way in class or anything like that, I apologize. This is a new thing that I think will help make more sense this year that I didn't do last year. And so what we're going to do is we're going to start looking at this first one. We obviously care about this carbon because it's attached to these four things. So we're going to go through the stuff that it has, and we're going to identify each of them and rank them in order from lowest priority to highest priority. So lowest priority is almost always, if there is one, it is always hydrogen. So hydrogen right here. There's a bunch of ways you can represent this. You can do a little tick mark. You can do a little circle. I'm just going to put a dot. I don't want it to be very intrusive. So I've got a green dot. I don't know how well that's going to show up on camera. I apologize if it doesn't show up. But this is green. I've got a green dot for hydrogen. After hydrogen, I've got fluorine, chlorine, bromine, and iodine. Fluorine has the next highest atomic number, because remember, that's what we're using here first is atomic number. So fluorine is red because it's the next highest. And you don't have to do it in this order. Just pick the order that makes the most sense to you. Try to keep it consistent. I feel like it'll help. So I've got number 1 is green, number 2 is red, number 4 is green, number 3 is red, because we're increasing in our priority here. After fluorine would be bromine, so bromine is going to be blue in this case. So I'm going to get my blue. I'm going to make bromine blue. And then finally, iodine is the heaviest. That means iodine gets to be purple. Iodine is the highest priority. So now what I'm going to do is I'm going to take my shell, my molecule shell here, and I'm going to zoom this up just a little bit and scoot this up a little. So I'm going to take this molecule shell, and I've got to try to get it to match up with the colored pieces of this. So purple is going to represent iodine. Iodine is going to be flat and going diagonally down. Bromine is going up. So I've got bromine, and then I've got iodine. Fluorine should be poking outwards from the page, so it's going to be going like this. And then hydrogen, your lowest priority, is poking backwards into the page. So if I tilt this just a little so you can see all of the pieces, I've got these two are flat, hydrogen is poking backwards, fluorine is pointing forwards. Once you have this, you're trying to figure out if it is an R configuration or an S configuration. R configuration will mean that if you point the lowest priority, which in this case is green, if you point it backwards, you should be able to draw a clockwise circle from purple to, where's that? Blue to red. It's going to the right or it's going clockwise. And if it's an S configuration, it will go the opposite way. So my lowest priority is hydrogen. Hydrogen is pointing backwards. Iodine is my highest priority, so I'm going to start with iodine, and I'm going to go from highest to lowest priority. Iodine is the highest. My second highest priority is bromine. Bromine is blue, so it's right here. So iodine, bromine, fluorine. This is a, sorry. Iodine is here, bromine is here, fluorine is here, iodine, bromine, fluorine, 1, 2, 3, 1, 2, 3. It's going in this order right here. That is a counterclockwise circle, so this must be S configuration. Now, if you don't want to use the colors, get a drink real fast. Okay, if you don't want to use the colors, or you don't want to have to memorize the colors, you can instead do just identify them each as a color. So like I'm going to say, I have these 4 colors. I'm going to use iodine as purple, I'm going to use bromine as blue, I'm going to use fluorine as red, I'm going to use hydrogen as green. You could also try to match these up to things that are actually in your kit, and then you would just write next to them, this is priority number 1, this is priority number 2, this is number 3, and this is number 4. And you try to hold it in that position so you could actually see it. Okay, let's go to the second one. The second one is a little bit interesting. So we've got sulfur, carbon, but we've got 2 hydrogens. So if there's 2 hydrogens, what do we do when there's a tie for priority? Well, there is no ties. If there is identical groups, if there's identical groups, that means Diamond is trying to trick you. It is not chiral. This is not chiral. If I go ahead and show you why, we'll go ahead and sulfur is a higher priority, so we'll make sulfur purple, and then we're going to make carbon will be our next highest priority, so carbon will be blue. If I go ahead and take off these pieces right here, and if I put on my 2 hydrogens, so I've got my carbon is blue, my sulfur is purple. One of the rules of chirality was there's no dividing line. There's no way you can divide it and draw a line of symmetry. And if we look, there is a line of symmetry right here. I could draw a line right down the middle of this. I could go right here, and it would be exactly the same on both sides of it. So it can't be chiral. It doesn't have a handedness, so it is achiral. Again, achiral is the scientific term you'll use for that. Okay, let's go ahead and go to our final example here. So we've got a chiral center. We have 3 distinct groups. This is a carbon and this is a carbon, but they're attached to different things. So we know that this one's actually going to be a chiral molecule. So what I'm first going to do is, well, I can tell my hydrogen is lowest priority because hydrogen is always lowest priority. After that, I have carbon, carbon, and oxygen. Well, oxygen's bigger than both of those, so oxygen is going to be my highest priority. So this is going to be number 1. But I need to figure out how to differentiate these carbons from each other. So we're going to have to use our tiebreaker rules. First tiebreaker rule says go to those pieces and list everything that they're connected to in order of atomic number. So in this case, it's attached to a nitrogen, a hydrogen, and a hydrogen. Now this is attached to a nitrogen, but it's triple bonded. And if it's triple bonded, or if it's double bonded, or, well, it's only double and triple bonds in this case, but if it's double or triple bonded, you actually count those as multiples. So this is actually the equivalent of it being attached to 3 nitrogens up here. So nitrogens tie at this first point, then this one has a second nitrogen instead of a hydrogen, so this chain will take priority. That means that chain will be considered a higher priority, so we're going to make that one blue, which is 2. And we'll make this one 3, which is red. So now I'm going to take my carbon. I'm going to put my blue up vertically. And again, notice I didn't have to do these extra pieces of the chain. If all you're identifying is R or S, you don't actually need that. So then flat on the page, I'm going to do my hydrogen because it's green. So it's green there. Poking out from this, I should have my alcohol, my purple, and then going back into the page is my red group right there. Okay, so I've got that structure built, blue going up, green going down, purple coming out, red going in. And now we do the exact same thing as before. We put green to the back, we rotate it so that purple is up top, and we check. Does it go 1, 2, 3, or does it go 1, 2, 3? Well, in this case, it goes 1, 2, 3. So this is going to be going clockwise. That means this is an R. I don't know why I did 5. I almost did it again. Numbers and letters are hard. R configuration, and just like this one was an S configuration. And you can actually double check this again really quick just by going back and looking at this. So this one had blue vertically, purple going down diagonally, and notice that compared to the shape this thing had, green is now coming out and red is going in, whereas here red is going out and green is going in. So this tells us that these would be non-superimposable, so they have to be opposites of each other. They have to be, this one is R and this one is S. Anyway, that is how you identify chirality. This is a little bit tough. This is, I kind of mentioned this before, this is the chapter where you're really hitting the wall of like, does this make sense? Or are you going to get really, really overwhelmed by this? So make sure that you're kind of taking the time with this and making sure you understand it, because this is something you will now have to do also in naming. We're going to focus on that next week more instead of this week. But when we come back from the weekend, you will be having to identify these things by chirality, as well as by all of the functional groups, as well as by double bonds. There's going to be all of these things kind of coming in all at once. So there's going to be a whole lot to do. Make sure that you are comfortable being able to do this. Now, after you get good at this enough, you'll be able to do this without necessarily needing to build the kit every time. But while you're learning, please make sure you use the kit. It will help you a whole lot. And if on the test you get freaked out or you panic and your mind blanks out, I'd rather you be able to default to this instead of using just kind of a mental image of what's going on there. Anyway, that's all I've got for you today in this video. I hope you have a good rest of your day. If you have any questions, please shoot me an email. Otherwise, this is Mr. Diamond signing off. Have a great rest of your day, everybody.